Hi. In this video, we'll look at special packet attacks. The first special packet attack that we are going to look at is the large ICMP packet attacks. In large ICMP packet attacks, what the attacker does is that it generates a lot of ICMP packets with large sizes, which means that these packets are going to consume a lot of network bandwidth. And since they are going to be fragmented, the end system or the target device is going to need a lot of resources for reassembling these packets, which may slow down the system, or the system might even crash down or restart because of all the load that is being generated because of these large ICMP packets. If you want to defend your network against large ICMP packets, we can configure the command firewall defend large ICMP enable, and then we can give the threshold that what is the maximum length that we want to configure for the ICMP packets, that any ICMP packets larger than this length should not be allowed through the network. Another type of attack that can be generated is the ICMP unreachable packet attacks. If any ICMP packet cannot reach its destination, and if a device has to, router or a switch has to discard that packet, it sends an unreachable message back to the source. Some sources, when they receive an unreachable message, they reset their connection with the server. So if an attacker is successful in sending an ICMP unreachable message to any server or any host, the host is going to terminate or close down its session. So the attacker can use the ICMP unreachable packets to tear down real connections or genuine connections between two hosts. In order to avoid this type of attack and avoid the sessions being closed down unwanted, we can issue the command firewall defend ICMP unreachable enable. This is going to make sure that ICMP unreachable messages are not passed through the firewall, and therefore the real connections or valid connections are not thrown down. The next attack is the traceroute or traceRT or traceroute packet attacks. An attacker can use the traceroute packets to discover the network topology or discover the path towards a certain destination. This is done by using the TTL field in the IP header. Whenever a TTL field reaches 0, the unreachable packet is returned back. And by looking at these packets, the attacker can find out the path towards the destination. If we want to defend against this attack, we can configure the command firewall defend traceroute enable or traceRT enable command. If we want to defend our network against these attacks, these different types of special packet attacks using graphic user interface, we can do that using the GUI. Once again, on the same page, single packet attack page, we can configure the special packet attack control mechanism. So large ICMP packet control or ICMP unreachable packet control. So we can, or traceroute control. So we can enable the defense against these different types of attacks. One important feature that we need to understand in order to understand the defense against these different types of attacks, or to understand the defense against the source authentication, is the URPF or unicast reverse path forwarding. What unicast reverse path forwarding mechanism enables or does on the firewall or any protection devices, that whenever a packet is coming from a spoofed source or from a fake source, and we want to check whether the traffic is coming from a real source, we can enable the URPF on the firewall. What the firewall does is that the firewall checks the source IP address of different packets when they are entering the firewall, and sees that if the source IP address exists in the firewall or not. If the source IP address exists in the firewall and the outgoing interface or the destination is reachable through the same interface through which the packet is entering the firewall, only then the firewall is going to allow the packet to go through. Otherwise, the firewall is going to deny or discard that packet. And this can be done using one of the two modes, either the strict mode or the loose mode. In the loose mode, the firewall only tests whether the source IP address exists or the network of the source IP address exists in the routing table. This is the loose mode. And in the strict mode, the firewall not only checks the presence of the route in the routing table, but also compares the incoming interface of the packet with the outgoing interface that is associated with the destination IP address in the routing table. So in this case, not only the presence in the routing table is checked, but also the interface is compared with the interface in the routing table, and only then the traffic will be allowed to go through. These two slides show the process of URPF check. And how we enable the URPF, we can go to the interface config mode, and there we enable IP URPF. Unicast refers path forwarding, either loose or strict, and then we allow the default route, that only default route can be allowed, which means that every traffic can be compared against the default route. And we can then configure an ACL as well, that if for certain types of traffic, even if they do not pass the URPF check, still we want to allow them, we want to add certain exceptions, so we can add those exceptions to this ACL. So this is how we implement URPF on our firewall. So this was all about special packet attacks and URPF, and I'll see you in the next video with different types of traffic attack defense technologies or anti-DDoS technologies. So see you in the next video.